In basic terms, a force is a push or a pull. Just like in basketball, where a player pushes a ball towards the net, or even just a person standing on Earth, the basketball and the person experience a thing called contact forces, because there was physical contact between the two objects. There are, however, non-contact forces. These most commonly occur due to gravity, such as a diver in the ocean. The diver is pulled towards Earth due to gravity. These forces can be represented with arrows because force is a vector quantity and has both magnitude and direction. These arrows are called free body diagrams, but we'll come back to those in a little bit. To really understand forces, we first have to understand the fundamental of forces and Newton's laws of motion. Isaac Newton, a famous scientist during the 17th century, developed 3 important laws that deal with forces and mass. These 3 laws are referred to as Newton's laws of motion. They provide the basic fundamentals for understanding the effects that forces have on objects. Newton's first law of motion. An object in motion stays in motion unless changed by a net. And remember, a net force is the sum of all the forces acting on an object. To really understand the first law, let's think of Mr. Yang and Mr. Huff playing hockey. When the puck isn't moving, it will stay at rest. However, when Mr. Yang strikes it towards Mr. Huff, it speeds across the surface, only slowing down a little due to friction. If the ice were totally frictionless, and we removed air resistance, the puck would keep moving towards Mr. Huff forever, until, of course, he stopped it in some way. This is the first law of motion. Newton's second law of motion is F equals ma. Pretty much. Kind of. In more technological terms, it's when a net external force, the sum of F, acts on an object of mass m. The acceleration that results is directly proportional to the net force. Imagine Mr. Huff and Mr. Yang on a road trip. Now imagine that their car broke down because Mr. Yang forgot to fill up the car. An angry Mr. Huff and Mr. Yang decide to push their car to the nearest gas station. The mass of the car is 1,850 kilograms. Mr. Yang applies a force of 275 newtons to the car, while Mr. Huff applies a force of 395 newtons. A third force, 560 newtons, is also acting on the car due to friction. How do we find the acceleration of the car? We can use Newton's sum of F equals ma equation to derive an equation for acceleration. A equals the sum of F divided by a mass. Now that we have an equation, we have to solve for the net force that is acting on the car. Let's draw a free body diagram. We have 275 newtons and 395 newtons acting in one direction, towards the right, and we also have 560 newtons acting in the opposite direction, to the left. The sum of F equals 275 newtons plus 395 newtons minus 560 newtons. This equals 110 newtons, this is the net force. From there, we can plug it into our equation we derived before. A equals the sum of F divided by the mass. A equals 110 newtons divided by 1,850 kilograms, which equals 0.059 meters per second. So, the acceleration of the car would be 0.059 meters per second. Now let's move on to Newton's last and final law of motion. For every action, there is an equal but opposite reaction. Imagine Mr. Huff and Mr. Yang out in space. Their spacecraft breaks down because Mr. Yang forgot to fill it up. An angry astronaut Mr. Huff and astronaut Mr. Yang decide to push their spacecraft to the space station to fill it back up. They both apply a force on the spacecraft plus h to the right and plus y to the right on it, and in return the spacecraft pushes back on the astronauts with forces negative h and negative y, equal in magnitude to plus h and plus y, but opposite in direction. There are several different types of forces, but the ones we'll cover are gravitational, weight, friction, tension, and normal force. Gravitational force is F equals G times m1 times m2 divided by r squared. Weight force is from the gravitational force that Earth exerts on an object. It's always pointing towards the center. Normal force is contact force. It is when one object exerts a force on another that it is in contact with. frictional force is when an object moves along a surface that has some kind of rough area. When dealing with friction force, always remember the fun equation. Friction force equals the coefficient of friction times the normal force. Tension force is when something is being pulled or suspended by. Forces are everywhere around us. Race car engineers at Formula One think of forces when building their race cars, and most notably one that they pay attention to is friction force. And that's pretty much it for forces. Remember, it's physics.